Hello good people, I would like to talk about the nomenclature of alkanes. Here's one I prepared earlier. What is its name? Well, if we number the carbons, it turns out there are 8 of them, which means this is an octane. So that was fairly straightforward. Let's make it a little bit more complicated. So here's the octane, and now I'm going to substitute a hydrogen on carbon number 2 with something else. I will place a bromine. What is the name of this compound? Once again, we number the carbons, and then we can say that carbon number 2 has a bromo substituent or a bromo group attached to it. So it's 2-bromo, and the longest chain has 8 carbons, so it's 2-bromo octane. Fair enough. You might ask, can we number in the other direction? In other words, can we go 1, 2, and so forth, all the way to 8, but this time right to left? We can, sure, we can place the numbers. What happens to the name? Well, in that case, the substituent bromo group is on carbon number 7. So the name would be 7-bromo octane. The rules of nomenclature tell us that we should always aim for the lowest possible numbers. In that case, that is 2, which means this is the correct name, this one is not correct. Let's make it more complicated. Here's the octane again. This time I will add 2 substituents. So we'll still have bromine over here, and we'll have a chlorine substituent over here. We are going to number the carbons as we have done before. And then we can say that carbon number 2 has a bromo substituent, same as before. So we are dealing with 2-bromo. Carbon number 5 has a chloro substituent. So we have 2-bromo, 5-chloro. Chlorine becomes a chloro substituent group. And we are still dealing with a chain of 8 carbons. So it is an octane. Could we have numbered the other way around? In other words, from right to left. What happens to the name if we do that? Well, then we have 4-chloro, pardon me, we still list the substituents in alphabetical order, which means we need to put the bromo group first. And if we look at the blue numbers, the bromine is now on carbon number 7, so we'll have 7-bromo, 5-chloro. Pardon me, not 5, 4. We are looking at the blue numbers. 4-chloro octane. Which one is the correct one? Well, once again, we look at the numbers. So up here, we have 2 plus 5, which is 7. And down here with the blue numbers, we have 7 plus 4, which is 11. So the lowest sum of all numbers is given by the red numbers. Therefore, that is the correct name. This one is not correct. Fantastic. Let's make it a bit more complicated. Once again, we have an octane. This time, I'm going to put the substituents a little bit differently. As always, we number the carbons. We are definitely dealing with an octane. And if we look at the numbering, we can say that carbon number 7 has a bromo substituent. So it'll be 7-bromo, 2-chloro, octane. Fair enough. What happens if we number the other way around? Well, in that case, the bromine ends up on carbon number 2, the way we have numbered it. So we'll have 2-bromo, and the chlorine is now on carbon number 7, therefore it's 7-chloro octane. Which one is the correct one? Let's look at the numbers. In red, we have 7 plus 2 equals 9. In blue, we have 2 plus 7 equals 9. So the numbers are equal. Bit of a conundrum. Luckily, the nomenclature rules have a provision for that as well. If the numbers end up being the same, then your aim is to give the substituent with the higher alphabetical rank the lowest number. In other words, A before B, B before C, C before D, and so forth. B before C, so bromo before chloro. Therefore, this one is correct, this one is incorrect. Let's make it more complicated. We'll bring the octane up again. And this time we will not add a halogen, we will add an alkyl group. What is an alkyl group? Well, pardon me, what is an alkyl group? Well, an alkyl group is just adding another alkane to an existing alkane chain. So here we have our octane, and now I'm going to add 2 more carbons here. If these 2 carbons were on their own, we would be dealing with ethane. So we are looking at this section here in yellow, and I'll make the bonds yellow as well. Hopefully that will make it clearer. So there is a carbon here, and there's a carbon here. If that was on its own, we would be dealing with an ethane. Because we've added it to an existing chain, now this whole thing is a substituent group, and it is known as an ethyl substituent group. So what is the name of this compound? Once again, we number the carbons. And we can see that the ethyl substituent group is on carbon number 4. So we have 4 ethyl octane. What if we number it the other way around? Let's have a look. Well, the other way around, the name would be 5 ethyl octane. And because we are aiming for the lowest set of numbers, it means that the red numbers are correct. So it's 4 ethyl octane, not 5 ethyl octane. Fantastic. Let's make it a little bit more complicated. So here's our octane. And now I'm going to add another ethyl group here. And you might be tempted to say, oh, well, it's pretty much same as before, right? We have 8 carbons on our main chain, and we have added an ethyl group, just like we did before. So therefore, this must be 2-ethyl octane. Well, it is not. You have to be careful that you are looking at the longest possible chain. In this particular case, the way I have numbered it here does not represent the longest possible chain. I could start my numbering up here. So I'll have carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So the longest possible chain is not 8, it is 9, which means I'm dealing with a nonane. And now I have to look, what are the substituents on this nonane? Well, I have this single carbon sticking out here. So 1 carbon, if it were on its own, it would be methane. But it is now a substituent group, therefore it becomes methyl. So the name of my compound would be 3-methyl, because the methyl substituent group is on the carbon 3 of the longest chain. And then it's not octane, but nonane. 3-methyl nonane. So please remember, check that you are looking at the longest possible chain. Then make sure that you number your substituents so that you obtain the lowest set of numbers. And should you have the rare case where you obtain the same set of numbers for two possible names, make sure that you pick the one that gives the lowest number to the substituent group of the higher alphabetical priority. In other words, A before B, B before C, C before D, and so on. That is all for now, and I will see you on the flip side.